Probability. So we're going to have a nice little recap. Straightforward lesson, I think, on using the probability scale and the basic language of probability. So hit pause, get the lesson objective down, get the keywords down, write starter underline when you're ready, hit play again, and we'll move on to the starter. So hit pause now. Okay, so here's our starter. Hit pause, have a go. Once you're done, hit play again and we'll go through the solutions together. Right, what's the multiplier for a 25% increase? Well, that means we're increasing our value by 25%. So we're going from 100 to 125%. Oops. And 125% as a decimal is 1.25. So our multiplier is 1.25. Metric to imperial conversions, you have to know. Okay, you have to know the unit. 1 litre equals 1.75 pints. So 20 litres is going to be 20 times 1.75. Might be easier if you do 2 litres equals 2 times 1.75, which is 3 pints. So 20 would be times 10 and times 10, 30 pints. And on the last question here, when it's midday in London, time in Hong Kong is 800 hours. So that's a time difference from midday to 800 hours of 8 hours. Time difference. J catches a flight at 4:20. The journey takes 8 hours and 20 minutes. So from 0420 hours, it's going to take him 8 hours and 20 minutes. So he's going to arrive at 12:40 hours. But don't forget the time difference of 8 hours, which we need to account for. And that takes us to 20:40 hours. That's his estimated time of arrival. Okay, so I want you to rag your work, rag it, and make any corrections necessary. So hit pause and do that now. When you're ready, hit play again and we'll look at the probability scale. And with probability, we have events. So an event is something that could or has already occurred. So we've got some events here. Mother giving birth to a baby girl, event. Getting a 6 when you throw a die, that's an event. Getting any of the numbers on a die is an event. Being born in the month of March. I wonder how many people are born in the month of March in the class. An event. Winning the national lottery, an event. Leaves falling off a tree in autumn, so that's a regular autumn event. And getting a 4 when you spin the pointer, that's an event. Out 1, 2, 3, 4. There are 5 possible options there. Right, so those are events. What I want you to do is to make a note of the definition of an event. So I want you to copy what's in the red box here. So everything in the red box, hit pause, write that down. That's what an event means. Something that could or has happened. Okay. So our probability line goes from 0 to 1. 0 is where it's impossible for an event to occur, and 1 is where it's certain to have occurred. And in between, we have varying degrees of probability, chance of an event occurring. Okay, so it's all about, can the event occur? If it's certain, it's 1. If it's impossible, it's 0. And then we've got varying degrees. Now, I'm sure you can remember the language of probability we use between impossible and certain. And the words we use are even, or evens, even chance, unlikely, and likely. So halfway between impossible and certain, there's an even chance, 50-50 chance, 50% or 0.5 if we're using the probability scale from 0 to 1. Between impossible and even, we're unlikely to occur, and so by definition, between even and certain, it's likely to occur. Okay, so we're going to describe the probability of each of the following events occurring. So what's the probability of a mother giving birth to a baby girl? Well, it's going to be evens, boy or girl, 50-50. Getting a 4 on the spinner. So there's our spinner with 5 options. 3 of them are 4. So 3 out of the 5 are 4. So the chance of getting a 4 on the spinner is more than even. It's going to be quite likely. What about the chance of getting a 7 on the spinner? Well, there aren't any 7s on the spinner, so the chance of getting a 7 is impossible. Leaves falling off the trees in autumn. Every year. Every year, same thing happens, so it's a certain event. Getting a 6 on a die. Well, there are 6 possible events, and getting that 1 that we want is 1 out of 6, so it's going to be unlikely. And winning the national jackpot lottery, while there is a chance, it's highly unlikely. Okay. So what I want you to do is just to make a sketch of the probability scale from 0 to certain and the language that's used. Okay, so a little diagram in your books for our probability scale and the words. When you're ready, hit play again. We'll move on. Okay, so we're going to look at outcomes. It's a chance of the number of things that can happen. Oh, I don't like that sound. Probability of an event happening can be located accurately if we know all the possible outcomes. Okay, so we know all the things that could happen. So we're going to have a look at all the possible outcomes of the following events. Throwing a die, all the possible outcomes. When we throw a die, we can get any of those numbers. Okay, tossing a coin, heads or tails. We've got 2 outcomes. Spinning the pointer, 1, 2, 3, 4. We've got 5 different colors that could occur. Okay, good. And a bit of classwork for you. So I want you to hit pause, complete those 3 questions. Once you're done, hit play again, and we'll go through these together. Right, so completing the probability scale should be straightforward enough. Halfway is evens, likely, going towards certain, impossible at 0, certain is at 1, and unlikely between evens and impossible. Number 2, label the events described below. Label the events described below on the probability scale, and it's popped up already, I can't avoid that. Chance of getting an even number when rolling a dice. So there are 3 even numbers and 3 odd numbers, so that's going to be halfway. Chance of winning the national lottery, very slim, so highly unlikely. And the chance of rain in March is that's looking about 90%, so it's almost certainly going to rain in the month of March. And for number 3, describe an event you think has a probability of 0.3. I don't know, I'd say Probability of rain on Friday. A certain event, probability of maths this week. You're doing maths now, so that's certain. And I don't know, 0.8, I'd say probability of a cup of coffee in the next hour. Okay, so that's how we write probability. So probability of rain on Friday, and we would tend to put then our value equals 0.3. Okay, good. So RAG rate it, and when you're ready, hit play again. Okay, so we've been using the language of probability. Now we're going to define probability in terms of values. Okay, we know it lies between 0 and 1. And there's our definition of probability of an event happening. Number of wanted outcomes divided by the total number of outcomes. So the number of wanted, what you want to happen, divided by the total number of possibilities. Okay, so we've got to look at the following events and see where we're going to place them on the probability line based on the probability values. So getting a tail when you toss a coin, it's going to be a half. It's 1 out of 2. And that's bang in the middle there. Getting a 3 when you throw a die. So we're looking at the exact values now, not just the language. So there are 6 possible outcomes. A 3 is just one of them. So that's going to be 1 out of 6. And that's going to lie just there. Okay. Being born in the month of March. So there are 12 months in a year, so it's 1 out of 12. So we're down there for number 3. Number 4, choosing a red cube from the bag. We've got 5 red cubes, the total, and 7. So the total number is 12. So 5 out of 12. So 5 out of the total number of possible outcomes. And so 5 out of 12. It's very close to evens. Getting the 5 on the spinner. There are 4 options, 3 of them are 5, so 3/4 of them are what we want, or 9 out of 12. So we can place that on our probability line there. And the last one is choosing a blue bead at random from the bag. 12 beads altogether, 11 of them are blue. So it's going to be 11 out of 12, which is just there. Okay. Good. So you need to write the definition of probability. So we need to write that down. So I want you to copy the definition down. Hit pause, do that. When you're ready, I've got a couple of questions for you to answer for me. Okay. So some questions for you. Hit pause. Have a go. When you're ready, hit play again and we'll go through the solutions together. Right, so let's have a look at some solutions here. On A, it says Bob's randomly selecting from a bag the number of colored tiles, 1 to 10. Probability he picks a 7 is 7 out of 10. Now, like we said earlier, you should be writing probability of 7, and that's equal to 7 out of 10. So we can see what that means. 4 or less, it's 4, 3, 2, and 1. So it's 4 out of 10 or 2 out of 5. So you should be writing probability of a 4 or less, and that's equal to 2 out of 5, and so on. Okay. Right, probability odd is a half, and probability of a multiple of 3. There's 3, 6, and 9. There's 3 numbers out of the 10. Then we got a survey conducted in a school. And we've got different teams: Spurs, Man U, Liverpool and Arsenal. And we're looking at pupils' favourite teams. Probability a pupil supports Liverpool. Now, there are 4 students that support Liverpool, but out of how many total possible outcomes? We need to add them all together, and that'll give us a total of 30. So out of 30, 4 of them support Liverpool, okay, which is 2 out of 15. So in your notes, you should have probability supports Liverpool. And that's equal to 2 out of 15. A London team, well, there are 2 London teams here, Spurs and Arsenal. So it's a total of 18 out of 30, which we can simplify then to 3 out of 5. And not Liverpool, well, if we add everything else together, it's 13 out of 15. Or probability of Liverpool is 2 out of 15. So not Liverpool is anything else. So you could do 1 minus 2 out of 15, which is equal to 15 out of 15 minus 2 out of 15, which is equal to 13 out of 15. So it might be quicker sometimes when it's not Liverpool. Just take the Liverpool one out, or not something out, because we know the total probability is going to be 1. And finally, bag contains 20 colored balls, some red, some blue. Keith knows the probability of picking a red ball is 2 out of 5. How many red balls are there? Well, we scale it up. Okay, so 2 out of 5 is red. Probability of 2 out of 5 is red. 5 times 4 gives me 20. So I do 2 times 4, which will give me 8. So out of the 20, 8 of them are red. Okay, good. Hit pause, make your corrections. If you haven't used this P and bracket sign, write it down now. Which is probably most of us. And when you're ready, hit play again. And 2 more questions. So hit pause, have a go. When you're ready, hit play again and we'll go through them together. Okay, so we've got the number of goals scored by Aston Villa even in the season. Mr. Walker has all the games and decides to watch one. He picks a game randomly. What's probability he picks a game with exactly 1 goal? 1 goal by Aston Villa. Oops. Well, as you just saw, we need to know the number of goals is 1, so there are 6 games with 1, but 6 out of how many? A total of 20. So 6 out of 20 will show 1 goal. Okay, or 3 out of 10. So you should be writing probability of 1 goal equals 3 out of 10. 2 or more goals. So let's change pen color. Make it easier to see. So 2 goals, 3 goals, or more than 3. 5 plus 4 is 9, 10, 11 out of 20. So we've got a probability of 11 out of 20. 2 or more goals is 11 out of 20. I'll just go back to red. And finally, cumulative frequency curve shows the distribution of height of 50 students. Estimate the probability that a student picked at random will be more than 164. So what we do is we look at our cumulative frequency graph here and we look for 164, and then we sketch a line up to the curve, take it back, so it's 40. That means that's at 164. More than will be from 40 to 50, so it'll be 10 out of 50. Okay, which is 1 out of 5. So we can say probability of greater than 164 is equal to 1 out of 5. Okay, good. That's excellent. What I want you to do now is I've got some classwork for you. So I shall attach that to the assignment, and I shall put it on this PowerPoint now. Right, so I want you to do the practicing skills and developing fluency. Okay, not going to take you very long at all. Good.